Okay, welcome back. This is section 4.2. We're talking about some composition and inverse functions and relations. In this video, we are going to talk about how to write a function that combines other functions, how to use a graph or table to determine values of the function's inverses, how to find the inverse, how to restrict the domain of a function whose inverse may not have been a function, so that way we can create a function, and how to use composition of functions to determine if two functions are actually inverse. Okay, function operations are almost identical to polynomial operations, only instead of actually talking about the polynomial as an expression, we're talking about it in terms of a function. And that function could be anything, not necessarily just a polynomial. So in this case for A, if we're doing f of x plus 3 times g of x, we can substitute in the expressions for f of x and g of x into this expression. So f of x is 3x minus 2 plus 3 times what g of x is, and g of x is x squared plus 5x minus 2. So when we rewrite this, we have 3x minus 2, and then plus 3 times g of x is 3x squared plus 15x minus 6. And so we combine like terms. So 3x squared plus 18x minus 8. And we know from polynomials unit that we can put any value we want in for x. This is called the domain, right? And all possible values for x are all real numbers. And we can do the same thing for b. So 2 times f of x, which is 3x minus 2, and then subtract g of x, which is x squared plus 5x minus 2. And so we distribute the 2, so we have 6x minus 4, and then subtract each term of g of x, so minus x squared minus 5x plus 2, and when we combine like terms, we have negative x squared. 6x minus 5x is plus x, minus 4 plus 2 is negative 2, and again this is a quadratic, so the domain is all real numbers because we can put any value we want in for x. Okay, we can also multiply and divide functions. So in A here we're going to do negative 2 times g of x, and so if g of x is x plus 3, and then times f of x, so if f of x is x squared minus 9, and now we're going to simplify. So if I distribute the 2, I have negative 2x minus 6 times x squared minus 9, and if I distribute, I have negative 2x cubed minus 6x squared plus 18x plus 54. And again, this is a polynomial, so when we talk about all the possible values of x, all real numbers. Division is very similar, except for one big rule that we need to remember. So first, f of x, so we have x squared minus 9 divided by g of x, which is x plus 3. Now, if we remember, way back when we first learned about fractions, we learned that we can never have 0 in the denominator. So that means that whatever's in the denominator can't be equal to 0, which means in this case, x can't be equal to negative 3, ever. So when we talk about the domain, we cannot include negative 3 in the domain. So our domain is not going to be all real numbers. From polynomials unit and quadratics, remember this is a difference of squares, so we can factor this to x plus 3 times x minus 3. And in fact, we're going to want to factor as much as we possibly can to see what simplifies. And so we recognize that we have a common factor of x plus 3 in both the numerator and the denominator. So x plus 3 divided by x plus 3 is 1. And so we're left with x minus 3 over 1, which we can therefore simplify to just x minus 3. And we say for the domain where, this means where, x is not equal to negative 3. Okay, I want you to go ahead and try these operations. Pause the video right now. Okay, welcome back. Here are your answers. Pause the video whenever you need, and we're going to move on to the next slide. Okay, so composition of functions. This is basically function substitution. So that is, we can put a function into another function. Most important rule is that we're always going to evaluate the inner function first. This doesn't ruin the rules of mathematics. Remember, we always do parentheses first. And then we're going to take whatever we get from the inside function and we're going to put it in the outside function. And the notation for this we read as f of g of x. These two things mean exactly the same thing. Personally, I think the first is a little bit more representative of the substitution that we're doing, and I think it's easier to see. But you can write it either way. There's nothing wrong with either of those. Okay, so if we have these two relations, f of x and g of x, if we're going to do g of f of x, that means we're going to take whatever we get from f of x and put it into g of x. And so this is telling us to put 0 into f of x first. So if we put in 0, the input for 0 on f of x is going to get us a negative 3 out. So f of 0 is equal to negative 3. And so we put that into the g function. And when we put negative 3 into the g function, we get 1 out. So therefore, g of f of 0 equals 1. And we can do that the other way around. So if we do the f of g of negative 3, that tells us to take negative 3 and put it in the g function first. And when we put that in, we get 1 out. So we get 1. So g of negative 3 is 1. And we put that into the f function. And so when we put 1 into the f function, we get a 2 out. So that means f of g of negative 3 is 2. And we can do this with functions as well. So if we do g of f of x, okay, first the f function, well, the f function says if you put 0 in, you get negative 3 out. So if we're writing our input values, if we put 0 in, we're going to get negative 3 out. And then we need to put that in the g of x function. So if we put negative 3 in the g of x function, we get 1 out. And so if we put in 0, we get out 1. If we put in 1 to the f function, so if our input is 1 in the f function, then our output is 2. And if we put 2 into the g function, we get 0 out. So our output of g of f of x is going to be 0. And then the last input is 2. If we put 2 into the f function, we get 2 out. And when we put 2 into the g function, we get 0 out. So when we put in 2, we get out 0. And so our last coordinate pair is 2, 0. Okay, we can do this with functions in addition to lists of points. So for example, if we're doing g of f of negative 3, we're going to put negative 3 into the f function first, and then whatever number we get out, we're going to put that into the g function. So if we evaluate f of negative 3 first, the function f of x says take the input and subtract 2. So we're going to take the input of negative 3 and we're going to subtract 2, and we get negative 5. So if f of negative 3 is negative 5, that means I want to evaluate g of negative 5. And the g function says take your input and square it. So the g function says take your input and square it. So we're going to take the input for g, which is negative 5, and square it, and we get out 25. So that means g of f of negative 3 equals 25. We can do the same thing in the other direction. So if we need to find f of g of negative 3, we always do the inside function first. So g of negative 3, remember the g function says take whatever your input is and square it, and our input here is negative 3. So g of negative 3 is 9. And so we're going to put that into the f function. So we're finding f of 9, and the f function says take your input, which is 9, and subtract 2. Well, 2 minus 9 is 7. So that means f of g of negative 3 is 7. We can do this even when our input is not a specific number, because if we're finding g of f of x, remember f of x is this function here. So f of x is x minus 2. So we want to find g of x minus 2. X minus 2. Well, g of x minus 2 means whatever g is, put x minus 2 in for the input value. Well, the g function says take whatever your input is and square it. And our input here is x minus 2. Well, x minus 2 squared would then be x squared minus 4x plus 4. Okay, here's a you try. I want you to go ahead and try these 3 examples. When you're ready, unpause the video. Okay, welcome back. Here are some answers. Pause the video wherever you think you need to. And here's the next example. Okay, go ahead and watch the More Examples video on composition if you have any questions about that. Otherwise, go ahead and move on to the inverse functions and relation video of this section.